I'm going to do a little, very quick review of what a couple of fellows out there, etherists, said, and then I'm going to address what they said. I'm going to answer them. I don't like to leave these things out in the open and letting people just think whatever they want. No, I want to get to the nitty gritty, and some of these etherists, they don't understand the arguments. And so I reinforce it. If they come back, well, they'll listen and understand, hopefully, and that's all we can hope for. Okay, so here it is. Etherist the other day said, he says, I can use some kind of medium out of my mind, referring to the ether. He said, what will that serve? I don't know what ether looks like. It's all supposed to be invisible and intangible. Not being good at drawing stuff, and doesn't mean that it doesn't exist. Okay, so those were his main arguments. Okay, and so let's go through them real quickly here, how we address each one. First one, he says, you want me to draw you the ether? Yeah, I do. And he said, I can draw some ether like you drew me your ropes. Okay, good, that's what we want. There I drew a rope, you can see it there in front of your eyes. That's more or less what a rope looks like. Okay. And he says he can draw you some kind of medium out of my mind, just like you drew the ropes. Yeah, but see, he doesn't do it. He's not drawing the ether. He's not illustrating the ether, so we know or understand what he's talking about. We can visualize, see what he's talking about, right? If it's an object, if it's a thing. And he says that obsession of yours is ridiculous. What will that serve? And it serves at least two purposes. Okay, it determines whether you understand the fundamentals of physics. And you can show us what's going on through your mind when you say ether. Okay, so those are the main points that we want answered. We want to make sure that this fellow understands. He understands what he's talking about when he says ether. Not so much us, we want to understand as well, but it starts with him. He's the guy who's proposing ether. He's the fellow who's supposed to make sure that everybody out there understands what he means every time he pronounces the word ether. Is it an object? Is it a concept? Is it a thing? Is it an abstraction? What is the ether? So you can't use the ether until you clarify all that. You can't begin in the middle of your movie and say, I'm going to start moving the ether. I'm going to be doing fluids, the flowing fluids and the fluids that flow. Flow. No, you can't start in the middle of your discussion, your dissertation. You got to start at the beginning. You got to present the objects. That's how we do it in physics. Okay, so he continues. He says, I don't know what ether looks like. Okay, so he confesses there. He doesn't know what it looks like, so that's why he can't draw it, I guess. Any more than you know what your threads look like. Not true. There's a thread. I drew it for him. That's what a thread looks like. Just take any string, thread, wire, whatever. That's more or less what we're talking about. Some thin, elongated object. Period. That's it. Nothing out of this world. Nothing out of the ordinary. It's all supposed to be invisible and intangible. Remember? And no, the word object. The definition of the word object is that which has shape. There's no provision for tangibility or invisibility. So it serves no purpose to really bring in tangibility and visibility into, when analyzing something such as the ether. We're not talking about touching or even seeing it. We're just saying if you're going to propose the ether as the medium that mediates gravity and light, no problem, but then show us this mediator, this mediator. Okay. Do you know what air looks like? Yeah, we do. And there you see I gave two examples. One is the air around the earth. It looks like a ring in 2D. It looks like a shell in 3D. And there you had the astronaut pops a balloon. Some air comes out of there, right? We color-coded it so you could see it. Okay, so you know what we're talking about. And both those, the air and the air in the balloon and the air around the earth, both have shape. In fact, everything that is made out of atoms had better have shape. Whether you can see it or not is irrelevant. The question is, does it have shape? It's a yes or no type of question. The question is not, what is the shape of a blob? Okay, I guess you could answer, it's blob shape. Okay, so whenever they say, what is the shape of? No, that's the wrong question. Does it have shape? Does energy have shape? Does field have shape? Does mass have shape? Does time have shape? That's the question. Does ether have shape? Well, the answer is no. Ether is a concept. That's why it doesn't have shape. That's why he can't draw it. He's trying to draw love. He's trying to draw intelligence, conscience. You can't draw those things, those words, those concepts. Okay, so he says not being good at drawing stuff doesn't mean that it doesn't exist. And he dismisses all this as word salad. It goes from one ear through to the next without anything stopping it in between. Okay, so to him these are just words because he doesn't pay attention. He thinks that doing definitions is known as word salad in his religion, I guess. Semantics, word wizardry, whatever. They don't do this. And that's the big problem with science today. They give you all these irrational explanations primarily because they use concepts as objects, meaning they haven't really defined their concepts as objects. In other words, they haven't identified any object. They haven't pointed and said tree, rock, house, and so on. They start using words as if you understood that they were objects. That's the way it's handled today. And that's a big problem because it's a problem of communication. Okay? You don't understand a physical interpretation because there is no physical. It's all abstract. It's all mass. It's all time, And so, if you're going to bend time and move the mass, what have you understood? And they get away with all that stuff in mathematical physics. But the dissidents are in no better shape. You get the electric universe, the etherists, the flat earthers. They do exactly the same thing. They don't realize. You have to start by defining your terms and pointing at the objects. Then you can start your presentation. No one does that. Everybody skips over those steps, says, well, you know what I'm talking about. No, we don't. Okay, so please be careful with your language, and point to the objects and define your concepts. That's the way it should work. Okay, so how did this fellow end this time around? He sent me a note there, and he put a comment, and he says, I was going to draw for you my ether, but nah, you would still find something negative to say. Why would I even bother? You're nuts. So, he ran away with his tail between his legs, and he got the boot. I mean, essentially he couldn't defend his religion, his ether. And that happens with all etherists. I haven't seen a single etherist in the last few years that has come here that has been able to defend either the definition of ether or defend ether as an object, as a thing. They can't do either one because they don't have a definition. They just say it's a fluid. It flows. Flow. Okay, that's what they say. And what is that? I mean, I need to see what's flowing, what's fluid. Okay, fluiding. So these people don't do that. They just jump in the middle of the show and they start, acting. You lost the first frames of the film. You don't know what the guy's talking about. So this is the problem. And everybody out there has this. Not only the establishment, mathematical establishment primarily, as well as dissidents. Okay, so they all make that same error. You have to identify the objects. You have to define your concept. Now, one fellow here, he says, ether would be like the seed of an apple. There is your object, a seed. Okay, like Jenny Appleseed there, plants the seed and all the trees grow. That's how they want it done. Well, what can I tell you? Maybe this guy is just BSing. Okay, that's all he's doing. Maybe he's not serious. Okay, but the reason I put that comment there, even if he was kidding, is that it reminded me of this. Let me show it to you first. What was this? 1999, and you have astronomy, how it all began. And you have Stephen Hawking, wrong one. Stephen Hawking and Neil Turok explain the universe's origin. Okay, and here I always keep these good ones. Says, let's see if I see it here. It says beginning and the end. Okay, the beginning and the end. So they're going to talk about the alpha and the omega. Beginning, Big Bang, obviously. crunch is the big crunch at the end. I don't know. And then here, give peas a chance. Okay, that's what the article was about. And here, let me show you what these fellows said. Okay, here's the magazine. I put it up here. Okay, it involves these fellows, Neil Turok, Alan Guth, and Stephen Hawking. Okay, how it all began there. And they said that the singularity that was already there looks more or less like a P. Okay, they call it the P instanton. And there you see it, singularity, instanton, and open universe. Okay, that's more or less the starting point. And so, you know, the question is, how did he get there? You know, I mean, did God put this P in there? Was he outside of the universe? You know, and a lot of religious folk, William Lane Craig, one of them, he says, you know, what you proved is God. Because what you're saying is that it all started at a singularity, and where did that come from? Well, obviously, the big man, right? So unless you can get rid of the big man, you know, I can put him in there. I can say, yeah, God made the singularity. How are you going to deny it? I mean, God was there first, and he put the singularity. What's wrong with that? I mean, if these guys are going to come up with a singularity, the P instanton, and say that was there, well, who put it there? And what was outside of there? That's the issue. I mean, if the P contains time, space, and matter, you know, what's around it? And of course, that's the same question as what is space-time expanding against? You know, this dark energy that's pushing everything away. What is it pushing against? And they say it's an irrational question. It's not a scientific question. We have no way of proving it. And it just is. And they give you a whole bunch of runaround. But they would never answer the question. What's outside of it? They can't tell you. Of course they can't, because they can't conceptualize what's outside if space is within the P. That's the big problem, the primary problem. Okay, so here it is. This is what they said in that magazine in astronomy. It says, the reporter asked, what does this new creation model look like? Good question. What does it look like? Draw it, you know, illustrate it. Neil Turok. Well, it's small and round, but not perfectly rounded. It has little dimples. It looks like a P. Okay? The universe comes out of one formula in a beautiful way. Oh, yeah, they love beauty. Great. This is the simplest way for starting the universe. The simplest way of starting the universe. So the reporter asks, how did he get there? Okay, Hawking says, it's meaningless to ask the question. There is no outside the P, no before the P. It just is an object implied by the very laws of physics. Okay, this is what the wording that they throw in your face. And so the reporter says, but what created those laws? And Turok answers, we don't know how to create physics from nothing. And that's the only question they really needed to answer. How did the singularity come into being? And he just says it there. We don't know how to create physics from nothing. And that answers pretty much all the questions. You know, and again, when I use my universal movie tool to illustrate what Turok and Hawking are saying there, this is it. You have God, right? And he creates something from nothing. And they always take you to frame 2. And they say there was something. There was a singularity in there. Might look like a P, like a circle, like a ball. We don't care. There's something there. But there was nothing, you know, in frame number 1. So how did something come from nothing? With or without God? I mean, if you want to put God in there, put him in there. I don't care. You know, just tell me the mechanism. Okay? How do you create something from nothing? And that's the only question that anyone who talks about Big Bang or creationism has to answer. And they never do. I mean, even the people who are in favor of God, no problem. You want to put God in the picture? I personally have no problem. Okay? The question is, how did God come into being? Did he have a mother? Was he there forever? You know, did he come into being? I mean, you got to answer that question. And you can't say, I don't know, because you're the guy giving the presentation. You're the guy who's proposing God. You can't say, I don't know. Then when you know, you come and give your presentation. Well, I'll allow you to give your dissertation when you finish your whole theory, your entire theory, and tell us where everything came from. If you cannot tell us that, then thank you. Come again next time, okay? See, under the rope model, very simple. The thread has always been there. No one created the rope because or the thread, the single thread that underlies all matter, because you cannot convert space into matter or matter into space. So the universe, meaning all the matter in the universe, right, was always there. It will always be there after we're gone as well. But and it's just a little thread, that very thin thread that weaves all matter, and it's what in space. In other words, we say in because I guess there's no other word to use there. It's space serves as backdrop. What is space? Nothing. What is nothing? The opposite of something. Nothing, that which doesn't have shape. Something is that which has shape. Period. We're done. But these people say, well, we don't know how the instanton got there. We don't know how God got in there, you know. No. Please tell us. When you're through with a mechanism that converts nothing into something, please come and give your presentation. That's the way it is. Okay, so what is this thingy called the ether, otherwise known as luminiferous ether? Well, it's in the Wikipedia we find this definition, okay, or description, right? Ether was the postulated medium, thing, object, okay, something, for the propagation of light. There was something there that allowed light to propagate, okay? Now, the question is, for the propagation of light, are we saying that light propagates through something else, a different medium called the ether, or is the ether itself light, the vibration or whatever of the ether? That's an important question to answer. It was invoked to explain the ability of the apparently wave-based light to propagate through empty space, a vacuum, right? Something that waves should not be able to do, okay? The assumption of a spatial plenum, space completely filled with matter, right? Or luminiferous ether, right? Space filled with matter, right? That's what ether is. Rather than a spatial vacuum, provided the theoretical medium that was required by wave theories of light. In other words, what they're saying in general terms is that space is separate, distinct from ether. Ether is within space. And for that matter, then you would have to answer, well, what is space then? And they made space made of particles, which is exactly what the ether is, because ether is what occupies or is within the walls of space. It's what fills space, so to speak. Like if space were a container that contains all the particles known as ether. Okay, so all that's got to be clarified. You got to start there. You got to show us what the universe looks like. Space, matter, ether, whatever you want to put in there. False vacuum, space-time, no problem. But you have to define it. You have to tell us what we're staring, what our starting point is. Okay, you can't just start in the middle of the road and say, well, you know what the ether is, you know what space-time is, you know what the false vacuum is, or what virtual particles are coming in from the vacuum. No, we don't understand that, because if virtual particles come in from the vacuum, make themselves real, momentarily, and then go back, then that means space is made out of particles. And if space is not made out of particles, and space contains these particles, that means you got to answer what space is. Okay, so and so on down the line, you got to clarify all that. You can't move beyond that. And the Greeks did their best, but they didn't do very good. And no one has done any better since then in mathematical physics. The ether required the existence of an invisible and infinite what? Material with no interaction with physical objects. So we have a material that has no ability to touch intangible material. Okay, do we have that? That's what everybody thought the ether was. And so when these people say it's a fluid, well, they haven't answered anything. First, you got to spend 10 years on your ether, on defining what the ether is or pointing to it, whatever. Spend 10 years developing your ether. Then we'll listen to your theory. 5 seconds will do. But 10 years is what it takes for you to really develop your ether, not theory, your ether hypothesis, your assumption. We need your assumptions, your suppositions. Okay, that's what we need. Okay, and just so you can see what the ether has been through the ages. Okay, here it is. You have all these fellows from Greeks all the way to really to the end of the 19th century there and a little beyond, but even people today talk about the ether. Very few, relatively, out of the enthusiasts talk about the ether. But this is what it's always been, just a bunch of dots, lines, you can say, segmented lines, little dots, and they're flowing in a given direction. Okay, that's what they show there. That's what's illustrated. That's what's in front of my eyes. Okay, and so all these, you could say particles, because I don't know how else to see them. They're all, the arrow just shows the direction in which they flow. So they have all this rain falling on the earth and the sun and etc. Okay, I don't know if it's all coming from one side, and that would be an important question. Why aren't these ether particles coming from the other side of the sun, for example, right? So, direction is important here, because it's easy to say, well, why do things fall to the floor? Well, because the ether pushes them. That's a problem because the Chinaman on the other side of the earth, his spoon falls in the opposite direction to me, and so also towards the center of the earth. That means the particles over there have to be flowing in the opposite direction. Okay, so again, the problem here is you cannot explain ether for light or for gravity. You cannot explain it with particles. And that's what the ether has always been, a bunch of particles. And that's why the ether really has died, but really it hasn't, because what is absolutely true, is that the false vacuum of the quantum mechanics, space-time, which is a bunch of events known as points, right? All these are ether particles. All these are ether theories. They're all ether theories. Humans, until today, until we came along, have always talked about particles, discrete particles. And you cannot explain a single phenomenon, invisible or intangible, out there in the universe with discrete particles. That's the whole problem. So anyone who does particles, meaning ether, space-time, false vacuum, whatever you want to call it, all those people will never be able to answer the questions of what is gravity, what is light, what is electricity, what is magnetism, etc. So you have to get rid of the particle hypothesis, the discrete particle hypothesis. And that's partly the reason quantum turned the particle, the corpuscle, the real ball, that Newton had in mind. They got rid of that. And today what do they accelerate? Quantities. Okay, they accelerate values, numbers followed by, units. Okay, here are, if you look up the word ether, on Google images, this is what you'll find, okay? See, you can see there, everybody thinks of the ether the same way, and that's what they use to prop up their theories. Okay, this is the assumption that it's a bunch of particles flowing in a given direction. So when I tell these ether as they come here that ether is just a bunch of particles, they say, oh, Bill, you don't know what ether is, you're wrong, blah, blah, blah. Okay, I'm wrong, no problem, I'll accept it. You tell me what the ether is. And they can't, they say, well, it's a fluid that flows. Okay, so here's the ether. Everybody wanted to know what the ether looks like. Here it is, okay? I'll show it to you for the first time in your life. That's what the ether is. Bunch of particles, they vibrate, and the vibration makes those waves. That's what it's always been. That's what always people had always in mind when they talked about the ether, especially in the 19th century when they said waves. Thomas Young suggested, or really it was suggested since the days of Huygens and Robert Hooke, that light was a bunch of waves, right? But Thomas Young showed through the slit experiment, at least, that apparently light had some kind of wave nature. And then Fresnel and others, later on Faraday and Maxwell, they got into the wave nature of light. And they were always thinking of this. They were thinking of ether vibrating. And when Michelson and Morley came around in the 80s there, 1887 I think it was, well, they got rid of the ether. They said, we can't detect any difference in light. When they split light, they couldn't detect the difference in speed of light in one direction or the other when the Earth just went around the sun. And so that's when they concluded, hey, there can't be any ether, especially not an ether like If you think of a sandbox, nothing moving, just sand there, just sitting there, that's one possibility. The other one is the grains are flowing. So either they flow or they stand still. And either way, you cannot explain anything you cannot explain light, specifically light. That's what we want to explain. And you cannot explain it with ether. And so the vibration of these particles or the standing still of the particles, it doesn't matter anyway, one way or the other, it's all garbage. Ether is garbage and has always been garbage to this day. And quantum mechanics relies on the ether. Still, it's a particle hypothesis, and that's what they show, that there's a bunch of particles there filling up space. They come into the real world as virtual particles and go back to form part of what? The ether. And like this Nobel Prize said, he says the vacuum, the quantum vacuum, the one they use every day in mathematical physics, is an ether. But they don't call it that because it's taboo. Robert Laughlin. Okay, so here's a flow chart for all those etherists who want to challenge what I just said. And this is what we're going to ask you. So I'm putting the cards on the table. You can't accuse me. This says, Billy, you're going to trash whatever I put in there. It doesn't matter. That's my job. Just like your job is to trash me, my job is to trash you. That's what the scientific discussion is all about. You know, if you can't defend your posture, well, it's not that you lost. There's no losing or winning in science. It's just that you can't defend your posture. You know, so you have no case. You're the guy who's supposed to present your case to the jury. The jury are your peers there. You know, where they're listening to you and they say, okay, what is this guy saying? What is your ether? What are you proposing? So you have to tell them. And this is what we're going to ask you. I'm going to lay it on the table for you to look at. This is the ether flow chart, okay? What I call the ether flow chart. Is the ether infinite or finite? You need to answer that question, okay, no matter what. Is it malleable or rigid? I mean, you can make it of a single piece or segmented, it doesn't matter. But if it's a single piece, you can say it's malleable or you can say it's rigid. You can say either one, no problem. But you have to defend these ideas, these proposals. And is it equal to space or is it contained within space? I mean, are ether and space synonyms? Right? Or is one contained within the other, meaning really the ether within space? Okay, and in that case, you got to tell us what space is. Like, is it container? Does it have, does it stop somewhere? And in which case, you got to tell me what continues. What encapsulates space? Draw it. That's the question. Draw it. Okay. Okay. So here, one fella out there, because a lot of these ethers say, well, it's a fluid that flows, flow. Okay, great. Okay, so it's a flow. And here you can see the type of problems that these people have in making their presentations, their dissertation. Instead of going out there and telling us, spending 2 hours on their hypothesis and saying, look, this is what a fluid is, right? They start in the middle of the show, the middle of the movie, and they start telling you what the fluid does and things about the fluid, but they never start at fluid. What is a fluid? And you can see here how they make their presentations. Let me show you this. And this is more or less how ether is in general talk and why it's irrational, because they skip over the important steps. We never get a handle on what they're talking about when they're already talking about the motion, what it does. Okay, here it is. To get all this fluid dynamics going, we start at the subatomic level that underlies molecular interactions. We average out the molecules by establishing the fluid as a continuous field. This continuum is then discretized spatially and temporally, whatever that will mean. Oh, great presentation, whatever that will mean. I mean, this is how the guy presented his case. In a prominent site, okay? So, yeah, they say it's a field. Like if you knew what a field is, what is it, a football field or a poppy field? What is it? And then, they just begin talking about the fluid. And that's more or less what all these people do. They listen to stuff like this, And then they just say, I'm going to say the same thing about the ether. It's a fluid, and let me tell you what it does. No, I haven't yet understood what the fluid, what your ether is. I mean, even in this case, you can see they're talking about a fluid. What is a fluid? Made of molecules, which are made of atoms, right? So is your ether made of atoms, made of molecules? And more than likely, the guy's going to say, no, of course not. Okay, then you gotta tell me a lot more about the ether before you continue, because if you're going to talk about a fluid, I'm going to say, oh, so you're saying they're made out of molecules and atoms. And if you say no, then you haven't started in the on the right foot. you skipped some important step there. Okay, so that's what the point is here. Okay, and so the issue for this fellow who talked about the fluid, right, is here. You can see it. We want to know what the black stuff is that gives shape or contrast or contour to each one of his molecules. He started talking about the molecules, the visible stuff, and he forgot about the invisible stuff, or the black stuff there that serves as contrast. That's what we want to identify. Is he talking about, are these particles or whatever, these molecules, in water? Are they in air? Are they out there in space? You got to identify the medium first before you can continue. You got to tell me everything that I see in that field of view. And so this fellow just jumped directly into fluids. He said, let me tell you all I know about the fluid. I'm an expert in fluids. Yeah, you might be an expert in fluid, but you know nothing about backgrounds. First, we need or about science for that matter. You need to identify the background. I need to see an object and a background. When you put a background, I need to ask you the question, what is that stuff behind it? You can't avoid that. And you can say, well, I don't know. No, you're giving the present. You can't tell me, I don't know. You put it there in front of me. You got to tell me what it is. You can't say that part, I don't know. Let me tell you the visible stuff. That's the way all these people talk. That's how they give their presentations. Okay, so more or less here, Fowler throws that same question essentially in my face, okay, which is correct, no problem, okay. He says, so according to you, the universe is finite. Absolutely not. There's no such thing as universe. Universe is a concept. Only objects can be finite, okay. So what's universe? Universe, the definition, matter and space. Two things there, really a thing and a nothing. Okay, so we have a thing and a nothing. We treat the nothing as a thing for the purposes of identifying the word universe. And so we're saying there's two things there, or two concepts. Okay, and so universe is a concept. You can't say the universe is this, the universe is big, it's small, it's infinite, because the universe is a concept. You either talk about matter, and you say that matter is either finite or countable. If you're going to talk about atoms, you can say there's a fixed number of atoms in the universe, no more and no less, okay? And then you can talk about space and tell us what space is. In our, here in rational science, space is that which doesn't have shape. That's what space is. That's a synonym of nothing, of vacuum, okay? And the single thread is an object. There you see it. That's what we propose. And as you can see, it's finite, okay, because it's a closed loop thread, okay, and it underlies all matter. It's always been there. It will always be there when we're gone. So he says, what's it into? What's outside the wall? And again, there is no outside the wall. You can say the outside the wall, I guess he's talking about the thread, is the black stuff. And the black stuff is not a stuff, it's nothing. It's the opposite of stuff. It's that which doesn't have shape. That's what the black stuff is. I put a square around it only so that to limit it, but you have to assume that this black stuff has no borders, no edges, no surface, okay, because it's that which doesn't have shape. That's why we can't draw space, okay. And the thread is within space, and it makes up every single atom, every single rope that interconnects every atom in the universe. And this is more or less the flow of thought. We have the single closed loop thread. Okay, you have to think of it as a rubber band, but that doesn't stretch. Remember, the thread does not stretch. And people sometimes ask that question. No, it's made out of a single piece. It's malleable, and it's closed loop, and it doesn't stretch. Okay, I don't know what other thing you want to know about it, but just ask. It's very thin. How thin is it? In physics, we say it's very thin. That's as accurate as it gets. Okay, we don't care about numbers in physics. We don't care how big it is. We don't care how small it is. We don't care how thin it is. It's very thin and it's very long. If we were to undo every atom in the universe, and that's what we use. We use the adjective very. Okay, or adverb in this case. Okay, it twines and turns into this rope-like entity, right? So that's what's going to make every rope that connects every atom, that connects every rope, that connects every atom in the universe. So we have atom, rope, atom, rope, atom, rope, all through the universe, and you can see there that every atom in the universe is interconnected. We're connected to an atom at the opposite side of the universe. Okay, that's why the Andromeda Galaxy is being pulled towards Earth, and Earth is being pulled towards the Andromeda Galaxy, because every atom in the Andromeda Galaxy is bound to every atom on Earth, including every atom in your body. Okay, so that's the assumption, called supposition, assumption, hypothesis. Okay, so that's what we propose. And so with that, now we can explain, what light is, the torsion of the rope that you can see up there, the 2D, 3D rope that interconnects two atoms. The atoms pump, expand, and contract, known as quantum jump. And when they do, they torque the rope. And the torsion of the rope is light. And the reason we have gravity is that all these ropes, they don't tug. Okay, they don't tug. But as two objects approach each other, the ropes fan out. And so you have acceleration of gravity. That's light and gravity in a nutshell there for you. Okay? Okay, so that's the model. Okay, so I don't know what the issue is. And here, just in case, we have a little evidence for those of you who want proof, evidence, etc., authority, tradition, democracy, all the people who voted for the theory. A lot of people are into that. In science, we don't pay any attention to that. Opinions have nothing to do with anything in science. Okay, but here we have evidence, proof, for those who want it. Here's Richard Muller. He's at UC Berkeley, and he says, so for example, here, if you have the Earth, there's a big mass here, and you have you with your little mass here. He drew it there on the board. You can see it. Every atom on Earth is pulling on every atom of you. You're also pulling on it. Simple, straightforward. How do you pull on an atom on Earth? How does one of your atoms pull on an atom of Earth? And how does one atom of Earth pull on you, unless there is some elongated entity that interconnects us? Intangible, invisible, elongated entity that connects the two atoms. If you can tell me that, hey, maybe you're going to win a Nobel Prize. There is no way of explaining that except that there is some invisible, intangible entity that connects every atom. Okay, and we made a pair of twine threads because we have torsion, and torsion is what light is. It's always been confused with this up and down transverse wave or standing wave or whatever. Okay, and what's been the problem? Well, the problem all these years, all these centuries, has been that people have never been able to see or touch the mediators. Okay, but you're supposed to make an assumption, like, they talk about entanglement. What is entanglement? One particle affects another, and there's no mediator. Entanglement means equal, right, or colon, right, followed by no mediator. That's what entanglement means. Okay, so every time you hear entanglement, it means no mediator. EPR, Einstein-Podolsky-Rosen, no mediator. That's what it means. So whenever they mention these fantastic scientific words, they mean no mediator. Action at a distance, which is the scientific term for black magic and witchcraft. Okay, that's what it is. Okay, so we have two things, two objects, two particles, whatever. And the question is, there's something happening in there that you can measure, but you can't see the mediator. Okay, so this one does something and affects this one, either instantaneously or after a while. It doesn't really matter. This one affects that one, but there's no mediator. You cannot see it or touch it. There's nothing there. Okay, so you make an assumption. Okay, you make an assumption, And whatever assumption you make, these people, the mathematicians, what they do, they put an equation to describe that. They describe what they think happened in there. Okay? And so let's say this one affects this one somehow. Again, through time, instantaneously, any way you want it, doesn't matter. This one affects that one. You can't see or touch what's in between. And so they put one in there, something in there. Okay? They forcefully put something in there with their imagination. They say, well, I think it's a bunch of invisible rabbits. They're jumping up and down, right? Maybe you found the wave nature of what's happening in there. You say, I think it's a bunch of rabbits that are just jumping up and down. Invisible, intangible rabbits, right? That are going from point A to point B, and that's how A affects B, okay? You can't see them. It's action at a distance, but really it's not really action at a distance. There is something there, and we're going to say it's a bunch of rabbits that are jumping. So this is what you visualize. Let me illustrate it for you here. This is what you visualize, okay? You see rabbits going from left to right, okay, on your screen. And you say, okay, and so now you go out there and you do your equations, you measure, and you come up with an equation, you win your Nobel Prize, you go on the talk circuit, right, because you've discovered what was in there. It was a bunch of rabbits that were jumping, okay? It turns out that, Mother Nature put something else, something different in there that you didn't even think about. And it's this. So worm, that's torquing. So what you thought with jumping rabbits was a torquing worm. Okay, and it's a little different. The equations that you would need for that would be different. So you went out there and did all this work, okay, on jumping rabbits. You had all these discrete rabbits and you put them in your equation. You describe them perfectly well. But it turns out Mother Nature doesn't have jumping rabbits. Mother Nature had, a torquing worm. And so the question is, the top one, the same thing as the bottom one there, I mean, if you make equations for the top one, turns out that Mother Nature has something different, has the bottom one. Have you wasted your time, 400 years of mathematical physics describing that which ain't, which are the rabbits out there, the discrete stuff? And not the elongated continuous worm that's at the bottom, that doesn't move anywhere, just torques in place. So it is important to identify, the mediator before you do any mathematics. Otherwise, you're wasting your time. And all these people are talking about particles and particles and particles. The etherists, the electric universes, everybody talks about mainstream. They all talk about particles. They all want to simulate everything with particles. The atom, 2 particles, a proton and an electron. Done deal. Then you say, is that your atom? Well, not really. We don't know what the atom looks like, but that's how they simulate it. And that's the one they're going to use for ionization, electricity, quantum jump. They do it all with this atom, the quantum jump, the electron jumps back and forth, around the proton, ionization, the electron leaves or leaves, or another one comes in there. So they all do it with a planetary model. And when you say, is that your atom? Is the planetary model your atom? Well, not really. We don't know what the atom looks like. So you need to know what your atom looks like before you go out there and do all this stuff saying electricity is the flow of electron beams from atom to atom. You cannot say that until you tell me what your atom looks like. Otherwise, you're doing all this thinking, all this measurement, all these equations, and you don't know what you're measuring. What are you measuring? Are you measuring rabbits, jumping rabbits, or are you measuring a torquing worm? You need to determine that before you do a lot of math. And that's the problem with the etherists. They start telling you about the fluids, but they don't tell you what this fluid is. They don't draw it for you. They don't illustrate for you. Okay? And if you want to illustrate, you got to see the whole thing. Like, I want to ask you, what is a table? I don't know what a table is. Here's the Klingon. You ask, what is a table? And you point to a table. You don't have to be the best artist in the world. You can get a sketch of a table. You can get somebody else's picture and say, this is a table. And you point to it, and now he knows what a table is. Is a table made out of atoms? Yeah. Is it made out of molecules? Of course. A table is made out of all these things, but we don't say, well, a table is what it's made out of, because then an elephant is what it's made out of. A rock is what it's made out of. A tree is what it's made out of. Are we going to count the number of atoms? Say a tree has 5 billion atoms and a table or a house has, 6 billion? Is that the way we define table? Is that the way we define house? No, we point and say that's a house, that's a table, that's a tree, that's a rock. And that's what we want to do with the ether. Point to something that has shape, and then you can do whatever you want with it. But that's the starting point. You can't do that, you got nothing. You got to work a lot more on your hypothesis.